as I only have 20 minutes, I want to make sure that we have some time for questions. So I'm going to speed up, and kind of rush a little bit on the slides. But before I start, how many of you have some continuous integration or continuous deployment effort in your projects? Can you raise your hands? Wow, that's awesome. Really cool. So my name is Antonio Silveira. I'm head of engineering for one of the groups at GoDaddy. I joined the company about a year ago. I came from Yahoo. And since I joined, I've been revamping a lot of the technology stack in the company. Moving from very traditional and old stacks to some more modern stacks. And as part of the process of moving to new, more modern stacks, one of them is removing a lot of stuff to Node.js and NoSQL. The NoSQL we're using Cassandra for our storage. And as part of that migration on the stack, we're also making a lot of changes on our processes. So that's what we're going to share a little bit with you guys, is what we're doing to change not only the stack, but also to change the practices that we're using to develop the products at GoDaddy. So the products that I'm in charge of are, majorly two products. One is the site builder, and the other one is the online store. So just so you guys understand, my target users are not you guys at all. So the users of my products are people that don't understand at all what HTML means, or JavaScript, or CSS. So my team builds tools for people that are complete, non-technical at all. So the one specifically that uses Node, and we're migrating to Node, infrastructure in Node, is the site builder. So site builder is basically a WYSIWYG product. We have millions of websites built with that and hosted. On a brand new Node.js infrastructure. I'm going to talk a little bit about that. I think it's important for you guys to understand a little about what projects are we, continuously deploying. So this is one of them. And it goes beyond also than just websites. We also help small businesses to have their Facebook pages, their Twitter profiles. So whatever presence they need, we have a tool for them to get online. So one of the projects that we have is we revamped. Before, we used to have a very traditional hosting infrastructure when I joined. Very traditional, I mean Apache, and a traditional hosting with Apache and files on a file system. So if you have a system that has Apache and you host one site on Apache, that's fine. So if you host 2 or 3 sites on Apache, that's okay. If you host 100, okay, it gets a little harder to manage. If you host 1,000 or 10,000, then it starts to get overwhelming. Right? So that's where using a traditional hosting approach was not working for us. We need to host millions of websites. And then we decided last year, given an idea from one of our architects, he's in the back of the room, Michael Cohen. He said, hey, we need to rethink the way we host those sites. And we look at Node, and we did a prototype in like a week. And today it's in production, and we took us about 4 months to build the first version. We're hosting hundreds of thousands of sites today on a completely new Node.js application that we deploy continuously to production. We deploy about 3 times a day to production. And just so you guys understand how much it evolved the architecture, I used to have hundreds and hundreds of boxes of Apache servers to host the sites. I could actually reduce that to 5 boxes of Node.js. So 5 boxes of Node.js, because of redundancy, I would say with 2 boxes would definitely serve. It's going to be more than enough to host all our hundreds of thousands of sites. Another thing that was interesting with this project was the response time of an Apache server is usually around time to first byte is about 60 milliseconds. On our new project, the average is around 16 milliseconds. So our new hosting platform for our sites, for our clients, it's much more performant and much more scalable than the traditional hosting. And this is one of the projects that we're using continuous deployment for. Another thing that we're doing is we're moving our application, the application that helps users build sites, into Node.js. It's being interesting. I don't know if I'm going to offend anyone, but we're moving from a very traditional Microsoft stack into an open source. I never worked with Microsoft stack before, so we're migrating off of .NET into Node. And it's been a very interesting experience for the team that is moving. One of them is productivity, right? So we had a joke that while you're compiling your stuff on Visual Studio, we could actually run and deploy the whole thing in 5 minutes, right? So it's very interesting. So before we go to how do we do continuous deployment, and I'm going to share a little bit with you guys what modules do we use and what packages we use. It's interesting to understand how it was before. Right, so how was our development process before? So basically, let's say we have the concept of feature teams. So we have small cross-functional teams that work in parallel, and they're quite independent. So they take a story in our backlog, they go and develop, and they implement that story, and then they merge back to master, and then we deploy. So let's say we have 3 teams working on this. We have 3 branches out of master. The other one, okay, I just finished this story. We just finished the sprint. We merged back to master. And now those 2 guys pull from master, and what the heck? Right, so it breaks everything for them because they were out of sync. And then, you go and you go to the nightmare of merge conflicts. And then you retest. Oh, I fixed the merge conflicts, I retest, I merge back, and then what the heck again? And it was a nightmare, right? So merge conflicts the whole day, spending whole days of merge conflicts. So when I joined, this was the process we had, and we had to change this. Another thing that we had in the past is before, we did, a lot of new people joined GoDaddy, and one of the first things we did was to replace our traditional, source control system. We had TFS. I don't know if you guys know. And now we have GitHub Enterprise. So they also help to change the culture around how you write code and how you share code. So this is just the development process. Once we develop a feature, how do we release it? So it's super simple. So just 16 steps. Right, so this was the release process before. Just super easy, 16 steps. And as you can read, some of them are very automated, like manager approval, QA approval, manually test each individual server. So this was the process before, right? So the thing with this process is, one, it's super fun, not. And so deploying code, deploying a new version used to take a whole freaking day. Right? So we started early in the morning, and at the end of the day, we're still rolling out this stuff. It was pretty terrible. Another thing that had started to happen is we're slow. We're slow, even though some people think that 2 weeks it's fast. Some features took more than 1 sprint to be developed. So we're talking about maybe a month to release something that we don't even know if it's going to work. Right? So how can we actually reduce the time for us to have a hypothesis, prove the hypothesis right, and then keep on evolving? I think that's the core goal of continuous delivery and continuous deployment. The quality of the code was pretty terrible as well at the time. So what you're going to see is continuous delivery and continuous deployment integration comes with a different mindset. It comes with a mindset of, we automate as much as we can, and we get quality as sooner as possible on the code. So super frustrating process. So then, we basically took, who knows Git flow, the Git flow process? So we basically made some changes to the Git flow process. So basically branch off of master, no changes there. Add your commits. We use pull requests for everything. Mostly not because we don't believe in pair programming. You do a lot of pair programming. But just to document what's being merged, and to get some more, responsibility to click the button and say, hey, I reviewed this stuff. So, just merge that. And then, of course, the code review And automation. So we added a lot of automation, and that's what I'm going to talk about a little bit with you guys. Another thing that we did in terms of changing the mindset of the team and to adapt was to get better coding standards. And we started to enforce that on our build process. Right? So we started to lint everything, and basically this helped the team to evolve on the way they write code. So you're going to see that, once it goes through lint, we started to get, hey, you're not writing against the coding standards. So, everyone can kind of write in the same way, the code. Another thing that we did is, we revamped our testing stack. So those are the modules we use, which probably most of you guys use as well. So we use Mocha, Chai, Sina and Chai, package and ProxyQuire for our testing. And it helps a lot on, of course, ProxyQuire helps a lot on stubbing and mocking external dependencies. That's great for external dependencies. On top of unit testing and integration testing with those packages, we also use Selenium for browser acceptance tests. The browser, so this is interesting because unit tests are super fast. They run in milliseconds. Integration tests, then they start to get slower. We're talking about seconds. Selenium tests and browser tests, we're talking about minutes, in several minutes. So the way we do is, of course, we separate our builds and our tests, and Selenium tests run in separate builds. We also have a lot of work to make them run in parallel with Selenium Grid. But our whole stack is automated. There is no more manual tests per se. Of course, we do some basic verification, but it's not needed to go to production. If you want to go to continuous deployment, you don't have the human factor there. But we have the three levels of testing in our project. So unit testing, integration testing, and browser tests as well. Browser tests, as they are very expensive to run, slow to run. They need more hardware. We have just a few of those tests that we call smoke tests. And everything runs through NPM. So we have all our scripts through NPM, and then we have our configuration, what do we want to run. It runs linting, it runs our unit tests, then it runs our integration tests, and then it runs in the developer machine our smoke tests. So that helps a lot. So NPM is a really good tool. So that's what I say. It's interesting. It's important to balance. Where you're going to invest your time in testing. We invest most of our time in integration tests and unit testing, and then the quality engineers help us on the browser verifications. This is always a interesting topic to go if you want to go, have some flame wars about what's the importance of code coverage. I think the importance of code coverage is not necessarily what's the percentage of code you have, because we all can write tests that assert nothing, and then you have in a report you have 100%. It's about knowing what you don't have tested. Right, so it's about understanding what you have covered and what you don't, and understanding the risk of that. We use Istanbul for that, for code coverage, and the report is pretty cool. I love Istanbul report for code coverage. What else? So once we get Mocha, all the unit testing packages and the process, and then we run everything. So we have some very strict rules. So one, we never allow merges to master if everything doesn't pass. So if it doesn't pass, it doesn't merge to master in a pull request. And we never deploy to production if it doesn't pass all the tests. That's why tests need to run super fast. And how do we do the integration between from commit to production? So we do that integration through a pull request hook. So as you can see, once you issue a pull request, we run our tests. You can see that it's waiting to merge. And once it passes, you're gonna get a message saying, hey, it's all well, you can merge now. Right, so that's an integration we did with GitHub. So basically, once you get the pull request passing, we use Jenkins as our continuous integration engine, and Jenkins will check out the commit, lint it, unit test, do the integration tests, the remote integration tests, and then depending on the result, is going to promote that build into one of the other environments. Then we have on our tests, we have all the hashes for all the builds in all deployments. And then we promote what hash we're going to test on our router. So we have a node router that basically maps a hash to the default route. And then we promote all applications are in production. And we just reroute which hash is going to respond requests from now on. So that allows us to actually easily switch the users to new versions and also roll back. So all versions are deployed. We just promote the router to the new hash. That's how we do. This is how we do also internally. This is how it does internally, but that's how we promote to production as well. Another important point is, so we did all of that, so now we're going to deploy. So, but after you deploy to production, that's just the beginning. You need to understand if the feature you work on, it still is effective. Is it working? Is it worth putting engineers to work on that stuff? So we have a lot of things for monitoring and data. Most of that stuff is not necessarily new, but I'm going to share with you guys. So what we really believe is, we build something, we build as fast as we can, we put in front of users, we collect data, and then, with the data that we collect, we figure out, okay, it is working, it's not working, it needs to tweak, it doesn't need to, it moved the engagement up or down. And for us to control that, we have some stuff that we use. So how many of you guys use Elasticsearch EOK? Do you guys use? Okay, so EOK is, I'm in love with EOK. I love this stuff, and it gives you a lot of flexibility to dig into your data. And we use ELK for our internal logging and extracting data from whatever logging we have. Of course, we use Winston as our transport for logging. We also use New Relic, the Node New Relic, for APM, for application performance monitoring. And in this case, we contributed back some of the code for New Relic to properly track queries on Cassandra. It wasn't that good, so we contributed back some of the query times for New Relic on Node. We also use extensively Google Analytics, so we track all the clicks, everything that we need to prove that the hypothesis is true or false, we track on the user experience as well. So it's important to understand that continuous delivery goes way beyond testing, right? So it's about the effectiveness of what you're delivering. It's about the effectiveness or you're building, and if it's worth for you to keep on allocating engineers and designers on that specific effort. And if it's proving right, okay, let's keep on improving on that direction. So it goes beyond just build and deploy. It goes after you deploy, if you're measuring right, and if you need to keep on deploying. So the process I showed you guys takes about 5 minutes from commit to run our tests to deploy to an environment, and then for us to be able to promote to production. So almost 20 minutes, 1 minute left. So a lot of people that I talk to, and a lot of the engineers that I talk to, they say, why do I need to deploy every day? 2 weeks, every 2 weeks is fine. And I think, the point is not why you don't need to deploy every day. The important thing is that you should have the option to deploy how many times you want. And then you choose to deploy it or not. Another important thing is that the deployment of a feature doesn't mean that feature is available to the users. So you need to separate deployment from availability of the feature. right? So this is very important as well. So for that, we use something, that is well known in the industry. We call it feature flipping, feature flagging. We call it feature flipping. So everything we deploy, so we deploy several times in production, but the feature is flipped to internal users or to a percentage of the users. So we can, gradually expose that feature to more users and collect more data about it. If the data is not in the right direction, we flip it back, and no one knows, right? So it should be super simple for you to flag something, and we are actually working on an open source project that we call Flipper. It's a Node project that allows you to flip any project, and basically it's just you need to implement an if in your code as any feature flipper. Don't forget to go back once the feature is in production and working and remove those checks. But we use Flipper. This is one of the engineers that built this stuff. It's on our GitHub page. And it's super easy. It's a YAML file that you can set some rules for it, saying, you know what, I want this feature to be available to 25% of the users, and just for special users that we call the internal users. And then we have the logic to check if the users are internal or not. And also, if you want some very specific users, who only those have access to that feature. For instance, only that feature team has access to that feature for some time. So we also support that. And if you want to expose for a specific group of users in a different rollout percentage, so you can also do that. So that is also open source. We're open source. A lot of these things that I'm talking to you guys, I only had 20 minutes. I'm sorry if I rushed a little bit. A lot of this stuff that we're working in Node and in Rails, we're open sourcing. So a lot of this stuff is on our GitHub page, github.com/GoDaddy. And that's it from me. I think we have time maybe for one or two questions. And we're hiring. If you guys love JavaScript and love continuous deployment and Node, please, reach out to me. Any questions? Anyone? No? Thank you.